Hi again. Right, everybody. We are going to be looking at molecular mass today. So that's your title, molecular mass. And we're going to be looking at chemical formulae, which we have just done. And we're going to be using information on the periodic table to calculate the relative molecular mass of compounds. Okay, so all will become clear. Your do now task is to remind yourself what we mean by the definition of an element and the definition of a compound, and remind yourself which number it is on the periodic table that tells us the atomic mass of an element. Okay, so this can be paused while you get that done. And hopefully you've finished your date, title, do now task and keywords. So let's go through the do now task. The definition of an element. So that's a substance containing one type of atom. A compound is a substance made up of two or more types of atom joined together. And on the periodic table, it is the larger number of the two numbers in each box that tells us the atomic mass of an element. So just as a reminder, hopefully you've got your periodic tables in front of you, but there is nearly always a key on a periodic table that tells you what the top and bottom numbers mean. And in this instance, the top number is the relative atomic mass. The bottom number is the atomic number. And if you remember that the massive number is the relative atomic mass number. Okay, so here it is again for hydrogen. It's that bigger number, which is usually the one written at the top. The bigger or massive number is the mass number. The mass number tells us the total number of protons and neutrons in the nucleus of an atom. So there are 2 protons and neutrons in a hydrogen atom. The atomic number tells us the number of protons, which is always the same as the number of electrons. Can you remember how to work out the number of neutrons? Okay, well, it's the mass number minus the atomic number. So the massive number minus the little number gives us the number of neutrons. Okay. So we're going to be looking at how we calculate the molecular mass of, or relative molecular mass of compounds. The periodic table tells us the mass of the elements, but we need to know how to calculate the relative molecular mass for a compound. Okay, so there are some steps here on the right. Molecular mass is sometimes written as big M with a little r. Okay, so you could put a side heading now, calculating big M with a little r, and that means molecular mass. Okay, don't draw this table yet. I'm just going to talk us through how we would calculate the molecular mass of carbon dioxide. So we're going to do this as a I do, we do, you do task. So to start with, I want pens down. You're just listening to me going through. Then we'll do a we do example where you can either watch and think along with me, or you can write down as we go, copying what I'm doing. And then there'll be some you do examples where you actually have a go at doing some by yourself. Okay, so step 1, we're going to use these steps to help us. Circle the different elements and their number. So if I'd written carbon dioxide down in my book, I would circle carbon because that's one element, and I would circle oxygen because that's another element. And I'm going to write those elements in my table. Okay, So the elements I have are carbon and oxygen. I then write down how many elements I've got, okay? Going back to step 2, identify the elements. You could write their names out in full if you want to here. Step 3, identify how many elements I have. So for carbon, I've just got 1 carbon because there's no little number after it. Oxygen, I've got 2. So in my table, I'd write a 1 for carbon and a 2 for oxygen. Step 4, find the mass or massive number of each element by looking at the massive number on the periodic table. So I first go to carbon on my periodic table, and I see that the mass number is 12. I go to oxygen on my periodic table, and I see that the mass number is 16. So I write those in my table. I now use a calculator and do how many, that's this number, multiplied by the massive number, and write my answers in the total. So 1 times 12 is 12. 2 times 16 is 32. That's step 5 done. Step 6, I add up the total column. So 12 plus 32 is 44. So 44 is the relative molecular mass for carbon dioxide. Okay, so we've completed this step by step using the chemical formula and the mass numbers from our periodic table to work out the relative molecular mass of carbon dioxide. Okay, we're going to look at another example now. This is a we do, so if you want to either just think along with me or jot it down as we go. Okay, so CH4, this is a chemical called methane. Okay, so first of all, we're going to circle the different elements and their number. So I've got carbon is 1 element, and then we've got H4. Let's circle that. If I don't know what these stand for, you probably know these by now. I'd look on my periodic table, okay, and I'd write down that I've got C or carbon and H or hydrogen are my elements, okay. So I've done step 1 and step 2. Right, what's next? How many elements do we have? How many of each element do we have? So you should be able to do this now. We've got, hopefully you realise we've got 1 carbon and 4 hydrogens. Hopefully you're doing this with me. Now have a look at your periodic tables. You need to find the mass number, which is the big number for carbon, and the mass number, which is the big number for hydrogen. Okay, so hopefully you've got there we go, number 12 for your mass of carbon and a number 1 for the mass of hydrogen. And what do we do next? We multiply how many by the mass number. So you should end up with 12 and a 4. We've done 1 times 12 and 4 times 1 to get 12 and 4. Next step, use a calculator. We've done that. Add up the total column. 12 plus 6 plus 4 is 16. So 16 is the relative molecular mass for CH4, which is also known as methane. Okay, right, I want you to have a go at this one by yourself now. So pause the video, work through the steps. and I'm going to go through the answers now. So you should have come up with, you should have come up with the elements hydrogen and oxygen. There are 2 hydrogens and a mass number of 1. There's 1 oxygen with a mass number of 16. So you should have ended up with 2 times 1 equals 2, and 1 times 16 equals 16, giving you a total of 18. I'll write that in now for you. Sorry, I thought I'd done that already. So we should have 2 hydrogens, giving us a total of 2, 1 oxygen with a mass number of 16. And then we should have done 1 times 16 is 16, and added that up to get, dearie me, to get our relative molecular mass of water as 18. Okay, right. You're going to have a go at these now. If you could write the chemical formulas down, and then I'll change the slide again so that you've got the instructions. In fact, even better than that. Why didn't I think of this before? Why didn't I think of this before, folks? Let's just these. Oh, dearie me. There we go. So, get rid of the... Oh my goodness. That grey box should disappear in a minute. So, the video can be paused now and have a go at those examples. Remember that where we've got brackets here, the little 2 applies to everything inside those brackets. Okay, so if you could pause the video now, and then I'm going to show you the answers. Okay, I'm moving on to the answers now. Get my big head out of the way. I'm still in the way. Okay, so for the first one, this is silicon dioxide. There is 1 silicon atom, and that has a mass number of 28. There are 2 oxygen atoms with a mass number of 16. So you should have done 1 times 28 plus 2 times 16. So that would be 28 plus 32, giving you an answer of 60. I know this is shown slightly differently to how you did it in the table, but hopefully you can work it through. The next one, ammonia. We've got 1 nitrogen atom with a mass of 14, 3 hydrogen atoms with a mass of 1. So 1 times 14 is 14. 3 times 1 is 3. Add them together, you get 17. So if you can be marking these as you go through. For lithium chloride, we've got 1 lithium atom with a mass of 7. 1 chlorine atom with a mass of 30. I've written 37. I think it might be 35.5. So if you've written 35.5, that's fine. You should have done 1 times 7, 1 times 35.5 or 37.5. I think that's a typo. And then added your answers together. Here we've got H2, so that's 2 times a mass of 1. Excuse my phone. We've got 1 sulfur atom, so that's 1 times a mass of 32. And we've got 4 oxygen atoms, so that's 4 times a mass of 32. 2 times 1 is 2, 1 times 32 is 32, 4 times 32 is 128. Add them together and you get 162. And the last one, we've got 1 magnesium atom, 1 times a mass of 24. We've got 2 oxygen atoms, so that's 2 times a mass of 32. 2 hydrogen atoms, so that's 2 times a mass of 1. So that's 24 plus 64 plus 2, which is 90. So hopefully you managed to get either most of that right, or even just parts of it right. If you are struggling, don't panic. I know it's harder when you haven't got a teacher in front of you doing it. Perhaps write down any that you're unsure about or any questions you want to ask once you've got a teacher back in the class with you. Okay, that's all the examples, I think. Yep, that's everything. Whoops. So well done, everybody. I hope to see you soon.